It's 3 p.m. Welcome to the Wolfram Technology webinar series for the year 2024. The topic for this talk will be what's new in the Wolfram Cloud. Before we talk about the cloud, let me please introduce ourselves. The company I work for is called 𝘂𝗵𝗵𝗁𝗂𝗺. It's a small privately held company based in Austria. We have around 50 employees, most of which have a background in some technical field. Most of those are theoretical physicists, software engineers, and data scientists. One of the most important business areas of 𝘂𝗵𝗵𝗁𝗂𝗺 is being a Wolfram technology reseller in Austria, Germany, and Switzerland. Our largest customers are the Austrian universities, which have a side contract with us, and the Fraunhofer Gesellschaft in Germany. And we also have a lot of commercial and academic customers in those three countries. What kind of services do we provide? We provide license and installation support for all Wolfram-related technologies, and we guide the customer from ordering the product until it's really installed on the machine, and the customer the customer can run the software successfully. We also provide technical support in using Mathematica, but as you know, Mathematica has over the last 25 years, it has grown into a huge platform for computations of any kind. And so we can only do the technical support as good as we can, and often we have to really rely on Wolfram themselves for solving different problems that our customers might have. Some other business areas of our company is data science, where we do data science project in a data science project relating to some industrial fields. We also do an Internet of Things application for industrial data, where we have created our own so-called edge device platform, which lets industrial customers attach their machines to the internet and then lets them observe and control these machines remotely. We also do industrial mathematics, where we do classical simulation and modeling projects. And we also have a very large standing in financial mathematics, where we have created the UNRISK product line. UNRISK is a product for the valuation of financial derivatives and for risk management. And it's also available as a Mathematica add-on, which then can equips Mathematica with functions for doing the risk management for financial derivatives. Now on to the subject, to the topic. What is the agenda for this seminar? We will look we'll introduce the Wolfram Cloud and look at its history. And throughout the whole presentation, I will always talk about new features that have been added to the cloud that you may not be aware of yet. We'll see how you can author Wolfram language in the Wolfram Cloud from both the Mathematica desktop version and from your browser. Once you're done with authoring, we'll see how you can deploy this Wolfram language code in the Wolfram Cloud so that other users which aren't necessarily Mathematica users can then use that code. And finally, we'll look at the Wolfram product stack as of 2024, because there have been made some changes to the product line here. What is the Wolfram Cloud? The Wolfram Cloud is a relatively recent development in the history of Wolfram research. If you are a Mathematica user, you probably know that Mathematica was started in the late 80s and is the flagship product has now more than 30 years of history. The Wolfram Cloud is much younger. It was launched in 2014, and now we have the 10-year anniversary of the Wolfram Cloud. And it has really also come a long way. What is the Wolfram Cloud? The Wolfram Cloud is essentially some application in the cloud identified by a URL, where you can then point your browser or your Mathematica desktop version to, and then you can access, you can store files in this Mathematica cloud in one of the input formats that Mathematica supports. These input formats consist of graphical formats, video formats, text formats, structured data formats like XML, Excel, JSON, but also compressed forms of these different formats. What else can you do? You can store generic Wolfram language expressions. As you might know, a Wolfram language expression consists of atoms and structured data of these atoms, lists, associations, and all this stuff. And these can be stored as Wolfram language expressions in the cloud. You can also execute, of course, Wolfram language code in the cloud. You can author Wolfram language notebooks in an interface similar to the one that Mathematica desktop provides. You can then share these Wolfram language notebooks with other users. And there's a comprehensive access control mechanisms where you can directly control who can access these notebooks in a read or read-write fashion. You can deploy interactive content in the cloud. You can deploy, for example, API functions which look like a REST function to other web services. And you can also deploy scheduled tasks there. One important thing is that the third party which makes use of the deployments here does not need to have anything installed related to Mathematica. The party only needs the URLs of the deployed applications in order to run the deployed Mathematica code. What are the cloud variants which are supported as of 2024? There are three different variants. The most widely known is probably the Wolfram Public Cloud, which is hosted by Wolfram at the URL we see here. The whole hardware is provided by Wolfram, and to the best of my knowledge, it's really run at the headquarters in Champaign, in Illinois, in the USA. The Wolfram Public Cloud has some restrictions. For example, it places some limits on the storage size that the size of the files that you can put there, and the amount of total data you can store there. It also puts some limits on the computation time that computation may take, and there's also a limit on the memory that a computation may use. This results in some limit functionality compared to desktop Mathematica, where usually these limits do not exist or are simply driven by the hardware you have. One important information is also that the deployed applications that you have consume so-called Wolfram Cloud credits, and these cloud credits have to be purchased from Wolfram. One new addition in the Wolfram Cloud variants is the so-called Wolfram Live Playground. Let me just bring this up here. It's a very nice feature. It's a really ad hoc Wolfram notebook where you can simply run ad hoc calculations by simply editing the cells in the browser. Like, for example, here, let me do for example, the factorial of 1042. And when I run this, you see it outputs the result. This is the fastest way to really run a mathematical computation anywhere without having to launch Mathematica or logging into the cloud. And also, of course, if you just want to do some experiments, this is really a very nice addition which can be used by any user on the internet. Besides that, there is also the Wolfram Enterprise Private Cloud. The Wolfram Enterprise Private Cloud is an on-premise installation variant of the cloud where you get a set of virtual images that you can then install on your hardware, for example, on your VMware Fusion software-based stack, and then run the Wolfram Private Cloud as if it were, and it looks exactly the same as the Wolfram Cloud, Wolfram Public Cloud, but it's hosted on your own machines. And what's also interesting here, that the payment model is here different. Here you pay in terms of kernels like the regular Mathematica version, and there is no Wolfram Cloud credit feature here. One new feature that Wolfram is currently working on that is almost finished is that besides the deployment based on virtual machine images, it's now also possible to do a deployment based on Kubernetes-based orchestration. That means that you will be able to run your Wolfram Enterprise Cloud, for example, in your own Azure or Amazon cloud which is then described by a Kubernetes-based orchestration configuration. But of course, if you have a local Kubernetes cluster, you can also use this form of deployment here. Let's now have a look at the Wolfram public cloud. Let me just close this one here, cloud files. This is usually the landing page of the Wolfram Cloud. As you see here, I'm already logged in with my account. So if you would not be logged in yet, you would have to log in here first, and this is then the landing page that you see. The Wolfram Cloud tries to mimic the classical notebook-based front end as closely as possible. That means I can, for example, here easily create a new notebook. This opens a new tab in my browser, and this tab then behaves as a notebook in the desktop front end. For example, I can run my simple calculations here. You see these regular input and output labels that we have. Of course, you can also do, for example, symbolic evaluations like you know from Mathematica. Like, for example, let's do this. Let's expand this one here. Expand Pythagoras, and you see it does it quite well. Of course, you can also do graphics. Let's just do a plot from a function here. Let's just say sine of x, where x goes from -pi to pi. I press Shift Return to evaluate the code. And you see here you get the graphics, and you also have the possibility to edit the graphics here, and to as you might know these things from the regular notebook frontend. Of course, you can also do manipulates. If, for example, copy this one here and wrap it with a manipulate, I can then do a plot of this function, and let's just say we introduce a frequency here, and the frequency goes from 0 to 100. And if we evaluate this, you get some interactive content where you can then draw a slider, and the graphics adjusts itself to the value of the frequency. Of course, you also have access to documentation. I can bring here up the documentation tab. This then lets me then browse the documentation. By pressing and selecting different pages, I can then directly navigate to the documentation. But a simpler way to use the documentation is to simply use the search feature, where, for example, let's look for a plot3d function. And the plot3d function is then shown here. And for example, I can then simply copy this example and paste it into my notebook and evaluate here. And also you see this 3D graphics, of course, can also be interactively studied. Here some recent browser technology called WebGL is used in order to render the graphics in a really efficient manner. One thing where this interface is different to the regular Wolfram notebook frontend is that notebooks are always saved automatically. That means if I can simply enter my name here, and the cloud will take care of automatically saving the changes that are made whenever the document is updated. If I close this notebook now, I can bring up, for example, a Cloud Files browser. The Cloud Files browser shows all the files that are part of my Wolfram Cloud account. And for example, here you see this demo notebook here down there, which we just edited. And by simply double-clicking it, it is opened in another tab, and I can then continue working on that notebook. Let's just go back to the main page, the landing page. This new notebook creates a regular Mathematica notebooks, but with recent versions of the Wolfram Cloud, there are new types of notebooks. For example, one is the Wolfram Alpha notebook, which lets you send input directly to the Wolfram Alpha intelligent search engine, which allows for human language input. Like, for example, I can say plot, let's just say, do please integrate sine x for me, and I can then Shift Return, and it will send the input to Wolfram alpha. Wolfram alpha will then translate this input to a Mathematica function input, and you see then here it automatically returns then the interpreted input. This is similar to the regular Wolfram notebook frontend, where you can here open a Wolfram alpha notebook. Another Wolfram notebook type is the chat-enabled notebook, which works similar as the Wolfram alpha enabled notebook, but here the input is sent to a large language model, and the large language model can, for example, be ChatGPT or another of these publicly available open models, like, for example, the Google ones or the ones from Microsoft. And you have to pay attention here when I type in something. Evaluate it. It will then automatically be sent, for example, to in this case to ChatGPT. But the problem here is you need to have a subscription with these different services in order to make this work with Wolfram, and you have to then set up the API key in order to make this work. Unluckily, currently I don't have such a subscription, so this is the error message that I get here. But it's similar to the chat-enabled notebook feature that you also have now in the front book here, chat-enabled notebook. Let's now close this here and move to the Wolfram notebook frontend. In the Wolfram notebook frontend, you have different menu commands and Wolfram language commands in order to work with the cloud. For example, I can use this open from cloud here. This will then directly use my account, which I'm already logged in here from Wolfram Mathematica. And I can, for example, if I scroll down here, just scroll down here. Where is it? Here's the demo notebook I created today. Sorry. Go back. Isn't. Where's my demo notebook? Here. I can then use the open command, and it opens the demo notebook which we just created on the cloud. And you see it contains the contents that we created. And the one important thing is, if I make a change here, like for example, I add some more code, and if I save now, the saving is actually down to the cloud and not to a local file. That means I can decide if I want to do the editing in the notebook front end or in the browser front end. When you want to work with the cloud from a local kernel instance, there are some functions and symbols available. The most important one is the cloud base. The cloud base tells Mathematica which instance of the Wolfram Cloud I want to work with. Here it's pointing to the public Wolfram Cloud. If I had an on-premise installation, I would simply set the cloud base URL to the local URL of my Wolfram EPC installation, and then the whole Wolfram session would then use that installation. Using Cloud Connect, I can connect to the cloud, and it will print out my account. There are some symbols which let me inspect the state of my cloud. Here I know I'm connected. And here, for example, $cloud connection shows me which cloud base I am connected to and which account I'm using. I can then inspect all the data, which is all the settings which are related to my cloud account. For example, here I have the various limits that are imposed by my current subscription plan. For example, I have a file size limit of 1 GB per file, and I have a total cloud storage limit of around 15 gigabytes, and I have around 50,000 cloud credits, which are provided each month, and I have this amount of Wolfram alpha calls that I can do. So this is really helpful in inspecting the actual properties that your account gives you with your subscription that you have. The cloud credits can also be queried by using this $cloud credits available. And once I'm done with the cloud, I can simply cloud disconnect to disconnect from the cloud. How do you access data in the Wolfram Cloud? There's a notion of a so-called cloud root directory in the cloud, which corresponds to a root directory which is directly linked to my account in the cloud. And this root directory, for example, can be queried here. And you see it has simply my short username in the URL. And if I get some information on that directory, you see that it's actually stored somewhere on a Unix file system, and it has some metadata like creation date, last access date, last modified date. It has permissions associated with it. Using set cloud directory, I can now change my cloud directory to another directory in the cloud. This is similar to the cd command that you would use, for example, on the terminal. And using cloud directory, I can inspect the actual cloud directory. And for example, if the directory does not yet exist, I could use the cloud create directory with the cloud object of Wolfram Seminars 2024 to create the directory. But here it returns an error because this directory already exists. Other than these directories, the main concept to work with data in the cloud is the so-called cloud object. A cloud object is like a handle to data in the cloud. And if you create an empty cloud object, it simply creates a new anonymous cloud object, which is stored somewhere in $cloud base. And if I inspect the file type of the thing, it says me the file type is none. Why is it none? Because no data has been put there. This is also shown by this information here. I can then use, for example, the cloud put command to put an arbitrary Wolfram language expression to the cloud. And if I do this, then you see that the file type changes from none to file, because now there is a file which exactly contains this content that I put in here. And if I do the information here, you see now that the cloud object actually exists. It has a user UID, and it has some rights and metadata associated with it. Using cloud get, I can simply having a cloud object URL, I can simply get this contents back and immediately evaluate in my local kernel session. I can also, instead of URLs, I can also work with regular file names. Like, for example, if I create a cloud object called test.txt, it will be put in my current cloud directory, which is Wolfram Web Seminars. And I can then use cloud put to enter a string, and using cloud get with the thing gets me back the text. And of course, I can also delete this data here again, and then it's missing again. In order to once you have worked with the cloud for some months or years, a lot of data will be accumulated in your clouds, and using cloud objects command, you can query all the different objects that exist in the cloud. You see here the cloud object was empty because I deleted the object here, so my directory is now currently empty. But with cloud objects none, you get a list of all unnamed cloud objects which you deployed somewhere or have somewhere. And usually there are a lot of these objects for a regular Wolfram Cloud user. Besides storing data, of course, you can run computations in the Wolfram Cloud. When you run a computation on your local kernel, the local kernel uses the resources from your local computer. My local computer here is a macOS Apple M1 machine, which is equipped with Apple silicon, you see here. And when you do the cloud evaluate of those things, what is actually happening that somewhere in the Wolfram Cloud, a machine is assigned to this evaluation. A Mathematica kernel is started there, and the evaluation is then run on this remote kernel. The result is sent back to your notebook frontend. Here, for example, if I do this here, you see the machine ID is now different. It's some Unix machine, and of course it runs on Intel hardware because ARM hardware is not really popular in the cloud yet. And this also means if you run the cloud evaluate multiple times, like I'm doing here, you see that the process ID is different every time. That means each single instance of a cloud evaluation gets assigned a new kernel. And one consequence of that is that it's difficult to work with symbols in the cloud. If I, for example, want to say set the variable foo to 10 and then evaluate the variable 10 times, you see it returns unevaluated result. Why is this the case? Because you get assigned a new Mathematica kernel instance each time, and this new instance, of course, has no idea of the assignment which was run on the original kernel. And then in order to make your symbols usable in the cloud, a new concept has been introduced called cloud symbols. A cloud symbol is simply a function where you put in the name and then you assign it a value. The cloud symbols are stored in the cloud symbol base directory, and the file type is directory. You can also evaluate enumerate all symbols that exist. For example, I've created a symbol y here, and also from a previous invocation there exists a symbol c. I can then, for example, query the information on these different cloud symbols, which then lets me see that they actually are stored as files on the cloud file system. And if I evaluate the cloud symbol here, you see it returns the value that was originally stored. And if I do the example from above now, where we simply assigned it to foo and use a cloud symbol now, you then see that it then behaves as expected, because each instance of the cloud accesses the cloud symbol. If you want to evaluate a function in the cloud, you can simply define the function in your local session and then run cloud evaluate to run the evaluation in the cloud. This will actually transfer all the definitions that are needed in order to run this code automatically to the cloud. I can also make use of, for example, the cloud symbol here in my computation. And once I'm done with the cloud symbol, I can simply use delete object to delete it again. Once you're done with authoring Mathematica code, either in the browser or using the Wolfram Notebook frontend, you may want to deploy these computations to the cloud so that other users can access these computations. The way to do this is the so-called cloud deploy function. The cloud deploy function works in the following way. For authoring, you need a subscription plan with the Wolfram Cloud, and for deployment, you need there's a pay-per-use model where you need to buy cloud credits, and when a third party then accesses your application that you deployed in the cloud, it will actually consume cloud credits until there are no more left, and then until all cloud credits are gone, then the deployment is automatically undeployed and will no longer be available for users. What actually can you deploy in the cloud? You can deploy instant web computations. You can deploy interactive content based on manipulates. You can deploy API functions which look like regular web services to third parties. You can deploy whole apps which are based on interactive web forms, and you can also deploy scheduled tasks. Let's look at a very simple example of deploying Mathematica code. Let's just say we want to deploy the date string function. The date string function simply returns the actual date and time each time you invocate it. And one thing you should do before deploying the function is to ensure that this function is actually available in the cloud. And you can do this with the Wolfram Language data function, where you give the name of the function and the property cloud support status. And here you get the result, yes, the date string function is completely supported in the cloud, and I can use it in my cloud computations. A function which is only partially supported is the launch kernels function, which launches parallel compute kernels. And that means it's restricted in the public cloud. And I can also, for example, query some cloud support nodes. And Actually, what it should tell you that it's only available in the Wolfram Enterprise private cloud, but not in the private cloud. How do I go about publishing? I simply connect to the cloud. I'm already connected. And then I use the cloud deploy function to deploy an expression to the cloud. And this here gives the name that will be then used in the URL that is created by the cloud. Here I'm simply deploying the date string function, and here this is the URL that can then be used to run the function. If I query the information, I see that it's currently that only the owner, that means me, is allowed to run the code that is behind this function. And I can, using the options here, I can simply set the permissions to public. And if I open this then in the browser, you see it simply runs the function every time I refresh the browser and returns the result as a text. And each of these invocations will take some will consume some cloud credits depending on the complexity of the computation that is being done. When I'm done with the function, I can simply use set options and permissions private to unpublish the function, and I can use delete object to completely remove the deployed function. There are some useful links on Cloud Objects Permission, where, for example, you can assign, you can set up the permissions in a way that it's only accessible for certain users, or you can set it up in a way that the user needs a certain token in order to run the computation. This is all described in a very comprehensive fashion in this URL that I've added here. Another form of deployment is the so-called Mathematica manipulated interactive content, where we define, for example, here we define a simple Mathematica manipulate function, where we simply, for example, have a small Monte Carlo simulation, which creates some paths in the simulation here. And as you can play around with the volatility and the drift and the time step and those things. And let's just say we want to have this similar interface now in the cloud. I simply do the Cloud Connect again. I deploy it to the cloud and give it the name Brownian. Then again, I set the permissions to public. And I can then simply directly run it in the browser here. This will simply render interface similar to the one we have seen in the notebook. And you see it's quite similar here, and you can basically do the same things that you are used to in the Mathematica frontend here in the browser frontend. I can also directly, for example, create code to embed this HTML in another page. Let me just go to this. This is also a web environment for rendering arbitrary HTML content. And here I've used the embed code function, which the option HTML. This creates an iframe code. If I paste this iframe code here and then do the run here, you see that this Mathematica manipulate is then embedded in the rendered website. And this enables you to, for example, to make a Mathematica application part of a larger application where the surrounding content is rendered with classical web technologies, like, for example, React or Frame-it, and then you put in the actual Mathematica code in an iframe, which then becomes part of the larger application. Let me just unpublish these things again and delete the deploy application. Another interesting application is the possibility to publish API functions, which look like a regular HTTP REST web access to other applications. For example, Mathematica has this very useful classify function, which is enabled, which is if you put in some text, it will tell you which language this text is written in. And if we look up the Wolfram language data on this classifies function, you see that it's supported in the cloud. That means we can embed it into an API function. An API function is the the wrapping of Mathematica code in an HTTP REST-like function where I have parameters, and I can then run parameters on these computations. Let's just define the API function here. And if I run it locally, you see that it takes the input as an association, and it works for both German and French. And let's just deploy this to the cloud here. Yes, let's just put this information about the object. I will have to forgot this one here. I have to set it to public so that it's available for public consumption. If I now I can now use this this text here, and you see it will simply run the code that is passed here. I can also, for example, use the web service from the command line. If I fire up my terminal here, let's make this a little bit bigger. And here I'm using the curl function, and the curl function I'm using the form option here to tell the curl to use this functionality here as a regular form. And if I run this here, you see it returns English, and by this you can really easily create web services which then can be embedded, for example, in Java code, in JavaScript code. And Wolfram Mathematica even creates the necessary glue code for calling this code from a JavaScript application. Well, of course, once I'm done, I can, of course, then again set it to permission to provide again, and delete the object again. Finally, the most interesting thing about the Wolfram Cloud is the possibility to develop and deploy really complex apps. Which really make use of a lot of Mathematica functionality and wrap everything in a so-called form page, which may have multiple user input interfaces, where you can then send complex data to the Wolfram to the deployed Wolfram application. Here, for example, let's just look at the find faces function. You probably know this very prominent selfie, which was done at an Oscar evaluation, I think, a few years ago. And the find faces function, which is provided by Mathematica, enables the detection of faces inside photos. For example, I can use this result here that I was given here in the faces, and then really cut using the image frame function to cut out the portions of the images which are actually faces. And the great thing about this function that it's also supported in the cloud. That means I can really use it in an deployed Mathematica application. And how do I do that? First, let's use the face checker function, which this face checker function is a function which simply gets submitted a photo and also a Boolean parameter where it shows timing or not. And if I run this function locally, for example, it renders the created detected faces and also prints the time here. And using the form page construct now, I can really now embed my face checker function into a form-like page. And this page simply says that one of the inputs is an image, and the other one is a Boolean input. And with this input here, that means that the input can be accessed as a association slot here using the hash sign here. And it runs the face checker function by simply forwarding the input from the form page. And here are also some metadata, like for example the appearance rule with the title that the face checker shall have, and the URL under which the object will be published. I have to set this to public again. Let me just copy this one here. Face check. Public, and if I open this application here now, you see it has now really created a form which contains the two user interface elements, the photo and the show timing boolean. The boolean parameter is turned into a checkbox, and the photo parameter is turned into a drag and drop based interface element, where I simply, for example, can then go to the desktop and drag into an image. In this case, it's an image of the royal family, and I say then show computation times and do a submit. And this will then simply now do the whole computation in the cloud. And once it's done, it's the first time usually it takes a little bit longer, depending on the kernel that it is getting assigned to. And you see now it has currently identified the faces in this photo here. And using this form page, you can really create very elaborate applications which have all different sorts of input, and then can work on this input to create additional output. Finally, let's have a look at the Wolfram Cloud products as they exist as of 2024. I've created a data set for that. The change that has been made in this year, that from now on, basically all Mathematica products include the cloud in some way. That means the existing products, the Mathematica Desktop plus Cloud, Wolfram 1 Professional and Wolfram 1 Personal products, they all have both the network, the desktop version and the cloud version of Mathematica included, and they only differ in the limits that apply to the computations in the cloud. For example, with a personal Wolfram 1 personal license, you only get the cloud storages of 2 GB, whereas with the professional products, you have 15 GB of cloud storage available, and also the cloud credits are much higher for the professional products. One exception to that is the Wolfram, the basic cloud, the free plan, which only includes the cloud and not the desktop version. This is basically can be used by any user that has an email address. And here the only really a severe restriction is that data expired after 60 days. That means if you upload some data to the cloud in the free plan, those files will be gone after 60 days. Another restriction is for the basic plan is that it's only available for non-organizational use. Another important limit is the computation limit time, which is the time that a single evaluation is limited by. That means, for example, if you really want to run long-running computations in the cloud, you need one of these professional products because the personal product is limited to 5 minutes, and the basic plan is even limited to just 1 minute of computation time. A similar limit exists for the session memory. That means this is the amount of memory that the underlying controller kernel that runs in the cloud is allowed to consume during a session. Similar data exists for the cloud credits. You see, for example, in my account, I have now this amount of cloud credits. And because of the deployments I did throughout this demonstration, the cloud credits have now been reduced by a few cloud credits. Let's look at the cloud credits and what this means for deployment. A cloud credit is consumed when, for example, every time a user calls an instant API in a deployed Mathematica application, 1 credit is consumed, and this is 1 credit corresponds to 100 milliseconds of computation. That means, for example, if you for the 50,000 credits that are included with with the professional plans, you get around 38 minutes of computation that the end user of your application can actually consume. Similar restrictions are true for the other forms of deployed Mathematica code, like, for example, deployed notebooks, instant forms, and scheduled tasks. And also another important restriction is when you do a Wolfram alpha call, it will cost you 5 credits per call. And sending an email, for example, if you want to have some business where you send out some email to customers, sending the email through the Wolfram Cloud will cost you 10 credits per email. Another important information regarding these cloud credits is that there are 2 forms of cloud credits. The regular cloud credits, which are part of your plan, they are renewed on a monthly basis. That means this works similar, like, for example, the plan that you have on your mobile phone, the allowance. It means you can use, for example, 50,000 credits per month. And when the new month begins, you get another 50,000, and the credits that you do not consume do not transfer over to the new months. And the other type of cloud credits are cloud credits that you can buy, and you can buy them here under the. If we look at the pricing here, these are so-called bought credits, and these credits never expire. They are simply they are simply used up by the computations that are done by your deployed content. And if you run out of those, you simply buy new ones if you need those. There are also computations that do not use credits. All the evaluations that you do in authoring notebooks and in development of your actual application do not consume credits. And also the Wolfram Alpha API calls that you might use throughout the creation of your Mathematica content will not be, at least you have a complementary set of calls that it's included there. But if you need to have additional ones, you can also purchase those separately. Yes, that's time's already up, and this completes my presentation. And we have now around, I think, 10 minutes for questions regarding the cloud. If you want to, you can also contact us via email if you have detailed questions, or if you don't have time now. So let's just do a Q&A session now.